Alright guys, I would say let's start. Um, I guess the other people they will catch up. Actually we're starting with more people than the last time. Last time I think we started with two and we ended up with all of us, right? So that's better. We're improving. Okay, so last time we were talking about the layered methodology, the TCP/IP protocol, and so on. You learned about the different layers. So now, as I said before, we're going to explore layer by layer, so you can learn about them. There are a lot of specifics, so there's a lot of things that we need to learn about them. Now, I'm going to start today with the application layer. Initially, I was thinking to start from the physical layer and go up to the application one, but the application layer is the one with which you're going to interact mainly as a programmers. So I thought it's worth it learning it now. And then later when you have some coding exercises, you will know about it and you will be able to implement some of the things that we learned today with Python. Okay. So we're going to start with the application layer, and then from the next lecture we'll start again from the physical layer and move up. Okay. Actually, we're gonna have two lectures on the application layer. One of them is today, and the other one is in, I think, in about 2-3 weeks, something like this. But I will tell you more later. Okay. So let's dive in. Okay. So, as we discussed last time, there are 5 layers: physical, data link, networking layer, transport layer, and we have the application layer on the top. And this makes the application layer quite different from the rest of the layers, and I will explain you about this a little bit later. But let's assume that we have two people that need to communicate. Let's say Alice wants to get a book from Bob is his name. I cannot see. Yes. So let's say Anne has a research organization and she wants to get a book from the bookstore, that is a web bookstore that Bob has. What she needs to do? So normally, as a user, she is going to interact with the application layer, and she would expect that the rest of the layers do their work under the hood. Okay, she's not going to interact with them. So we can say that we're having a logical connection between the application layer of Alice and between the application layer of Bob. So what Alice will do, she will send a request and then Bob will provide her with a response. Okay, and the request is going to tell Bob which book do I want, and then Bob will provide the book. So you can see that even though the message that Anne sends will go through the internet, obviously we'll have local ISP or internet provider, then the traffic will be routed to multiple switches, then it will go to the Bob local network, and then it will reach Bob. Okay, although those complicated things are happening under the hood, right now we're not going to care and talk about those. Okay, we only care about the communication with the application layer of Alice and the application layer of Bob, and how this works. Let's go to the next one. Okay. Now, obviously, the application layer, the main purpose. Okay. The main purpose of the application layer, obviously, is to provide services to the user. And to provide those services, we use different types of protocols. As I said, application layer is unique. So on the other layers, let's give an example, the transport layer protocol. If we make a change or we create a completely new protocol, for example, on the transport layer, we have TCP and UDP protocol, right? If we create a brand new protocol there, this means that we also need to change the layers above it. So we need to change all the protocols into the application layer as well. If we do that on the physical layer, we'll have to change all the 5 protocols, all the 4 protocols above it. On the application layer case, we don't have any protocol above the application layer, which means that any programmer can create their own protocols and applications. Yeah, hello, come in. So which means that every programmer can create their own protocols, applications, and so on. So because of that, we're having two different type of protocols that are inside the application layer. We can divide them in two ways. Okay, so those are the standard application layer protocols and the non-standard application layer protocols. So does any one of you know any standard application layer protocols? So those are the most popular protocols with which the internet and most of the programs work. Can you guess any of those? Come on, try. You try. Any protocol? How do you go? Okay, so when you go to access a web page on the internet, which protocol do you use?
Yeah, upstream and downstream applications.
Yeah. So let's say when you write a website, okay, you write the name of the website, and before that, what do you write?
HTTP.
Yes, exactly. You write HTTP. So the HTTP is the protocol, the application layer protocol, with which we retrieve web pages, right? And this is a standard protocol because obviously every web page is using this type of protocol. So for the standard protocols, we will have well-known sockets from which they communicate. Okay, they are always going to stay the same. Other type of standard protocols are, for example, the SMTP protocol, which is responsible for sending and receiving emails. And today we're going to talk in detail for the HTTP, for the SMTP, and so on. So you're going to learn about those as well. Then the non-standard protocols. So those protocols are, let's say if I'm a programmer and I'm building like a brand new application and I don't want to use any of the protocols that already exist, then I will build my own protocol if I have a client and a server that I'm able to program so they are able to communicate, right? I will use a protocol for them to communicate. And I can give you an example. Actually, from my work, I have a very good example for that. So let's say I'm working in a medical company and we're building medical instrumentations that are taking samples automatically, right? And let's say we have one instrument that is taking the samples and the other one that analyzes what's inside those samples, right? So we have two instruments. So for them to communicate, we don't necessarily want to use the predefined, the standard application protocols because they're not going to be efficient in our specific case. For that reason, we're going to create our own protocol specific for those two instruments, and then they will be able to communicate and exchange information in a very efficient way. And we don't need to modify any of the rest of the layers in communication because they're under the application layer. So this is very convenient. All right. Now, once we know about the different variations of the protocols, well, there are also different variations on the way that different systems interact between themselves in the application layer, right? So there are two main types that are used today. One is way more popular than the other, okay? But we can see a real-world examples for both of them. So the first one is the client-server, which is the traditional, so they're called paradigms, okay? This is the way we interact with different devices in the application layer. So client-server means that we have a client, right? So let's say we have a computer, that is a client, and we have a server somewhere. And the client requests services from the server, and the server provides those services to the client. Okay, that's it. Most of today's internet works with client-server based paradigms, and you'll see later in the application layer protocols that the main services are using that. Okay, so let's actually see if I have a drawing for that. So You get a better idea? Okay, great. Yeah, so this is the way we're using the client-server paradigm. So let's say you have multiple clients, right? Anywhere around the world, and you have a server. So let's say the server holds a web page, right? So if you want to see this web page, you're going to send request to the server, and the server then is going to provide you that page as a response. Okay? You can see that this server can be anywhere. It can be into your own network, the local area network. It could be anywhere around the world. Okay, we can see that every day, right? So, can you tell me some of the disadvantages for having this structure? What do you think? Even if you don't know, try to come up maybe with something. What are the some major disadvantages of that? Okay, let me choose somebody. Okay, you. What do you think?
The internet will be slow.
Yes, okay. It's a good start. It can be, yes. Anyone want to elaborate more into that? Yeah, so we can have slow service time to time. For what reason? Okay. So when we have one server that is holding, let's say, a page or a file, then the more requests are to this server, obviously the server is going to become slower and slower and slower because we're going to queue the requests, right? The server has some limit, and the responses coming out from those requests will have a delay, or even depending on the security levels, the server can also crash, right? So this is one major disadvantage, obviously. However, with the transport layer protocols that are quite stable, this paradigm is very, very popular, and it's the one that is mainly used today. But there's another one that is also quite popular for some applications, and this is the peer-to-peer paradigm. So with that one, uh, the the provider of the services is not a server, right? Every computer on the network has exactly the same status. It's a pair. So all the files that are exchanged, uploaded or downloaded, right, are exchanged between those computers. So if a computer is into pair-to-pair network with other computers, any computer can provide the service to the other ones. Okay, so what do you think? What services this would be applicable for? It's a little bit more difficult, but there is one specific service which uses pair-to-pair communication. Okay, so one very popular service is okay, I'm not going to ask you, but for the torrents, right? If you download torrents, you know what torrents are, right? When you want to download movies, for free and stuff like this, right? This is where you download torrents, and there you are downloading, right? But also you're uploading. So the less people are seeding or providing their own device, right, to get part of the movie, for example, which some other person can use your computer as a service, right? So the more people are seeding, the faster the traffic is for a particular movie to get downloaded. So this is a perfect example for the peer-to-peer. There are also other services like internet telephone. So let's say if you want to have a call with a normal phone and let's say with an application, you can also use peer-to-peer paradigm because you don't necessarily want your call to go through a server and then go to the computer when you're speaking. Even with that, most of the today's applications that are for communication, for example, WhatsApp or another one, Messenger, they are still using client-server based paradigms. But it's important to know this one since it exists in the internet. Okay. All right. So now let's talk about the client-server programming, or actually, most importantly, we're going to talk about sockets, right? So socket is something uh, very important when communicating with different devices, and when you become one day programmers for a company, you are going to use sockets in one way or another, okay? Because you will want at some point to remote login to a device. You might use the SSH or the Telnet protocols, okay? But actually every protocol is using sockets, especially on the client server paradigm, okay? And we're going to talk about this a little bit later. But how sockets work and what socket actually is. So obviously we already talked about all the 5 layers, but what is the socket doing over there? I mean, what's its purpose at all? So socket is the API between the application layer and all the rest of the layers. So as I told you earlier, we want the rest of the layers on the device to be hidden. We don't want to interact with them, okay? We want their services to be available and we don't want to think about them. So for that reason, we're going to create a socket which is going to encapsulate all the rest of the layers, and it is just going to provide services to the application layer. Now, so how we can describe a socket, right? So here I bring you a very simple example of a socket. So let's say we have an application, and usually when we want to interact with the application, we provide some inputs to the application, right? So the application reads from our keyboard, right? And then the application also writes to the monitor. So we take inputs from the application, takes inputs from the keyboard and writes to the monitor. So we can call the keyboard a source and the monitor a sink. If an application interacts with a file, for example, we can do both. We can read and write from that file. So socket is exactly the same thing, like a file. So let's say, you know, if we have a file and we want to work the application, want to do some actions on this file, the application can read the data from the file and can write new lines to the file. So with the socket, we're reading and writing just to another application, to another process, okay? So as far as the application is concerned, we're taking data from the socket and we're writing data into the socket, and this data goes somewhere. Come on guys, yeah, no problem. Okay, and here is how the communication between a client and a server looks like when we use sockets. So the sockets are having a logical connection and they're connecting the client process and the server process. Those processes are in the application layer. So let's say if the client wants to get some service from the server, they send a request to the socket. This socket has a logical connection with the server socket, and it provides a request to the server. Then the server sends a response to the socket. It passes the logical connection, and we're going to the client process, and we get the required data. Okay, so let's see what exactly we can use for the socket address. So as I said, the sockets, they are making communication between the operating system and our application, and the two sockets have logical connection between themselves. Okay, pretty simple. Now, in order for this communication to happen, so let's say if we want to get a service from a server, we cannot just use any socket around the world. We need to find a specific socket where we want to connect. So for that reason, a socket address has two components. So it has 32 bits into IP address, okay, and it also has a port number. So from which layer the socket gets the IP? It's a question for you guys.
Network.
From the network layer, correct. And from which socket, from which layer we're getting the port number?
Transport layer.
From, yeah, correct. So yeah, we're getting the two from the layers that you mentioned, yes. And every socket uses two addresses, a local address and a remote address. So the local address is obviously the address that I have, whether I'm server or I'm a client. So let's say the local address for the client is the remote server is the remote address for the server. And on the other side, on the server side, the server has its local address, and the remote address is the address of the client. Okay, it's pretty simple. Now let's see how they talk with each other. All right. So now the other question that we have is how do you obtain those addresses? Okay, in order to make the communication. So on the server side, in order to obtain the local address, we need to have our own IP address, which obviously we do have, and we also need to have the port number of the application that we want to use. Now, when we use the most popular or the standard protocols, we already know those ports. We know the ports for the HTTP, for the SMTP, for the FTP. Those are known ports, and for every device they are the same. So we also have the port. So we're good with the local address, right? On the server side. Now, for the remote socket address, obviously here we also have the port as is well-known port. Now, the IP address of the client, how do you think we get it? Do we need to do anything to get the address from the client? No, we don't need, because the client is the one that initiates the service from the server. So the server should always be on, and the client then asks the server for a service. So in order to ask, the client needs to have the server IP address and to send to the server their IP address as well, so the server can provide the service. So the IP address to the remote socket on the server side comes from the client, and the server doesn't need to do anything about it. Okay? On the client side, obviously we have our own socket address, but here is the issue with getting the remote socket address. So in order for the client to access the server, it needs to already know their IP address and the port number of the application. And the main difficulty comes for the IP address. So in order for us to establish a communication between a client and a server, the client needs to know the IP address of the server. And I can give you an example for when we access a web page. So we use the HTTP protocol, and we need to provide a specific name of the website we want to access. If we don't know this name, we will never get the service from that website. Okay? So this name of the website is actually closely tied with the IP address of the website using the DNS system, but we're going to talk about this later. Okay? For now, remember that we need the IP address of the server in order for it to be accessed by the client. All right. So now we know that in order to get a message or some action from the server or a file, we need to have our server always on. So the server should always be on. It should never be turned off. If it's turned off, we cannot get the service. However, the process on the client side turns on only when it needs a service. Okay, so the server always needs to listen, while the client only turns on when it needs a service. Now, depending on the transport layer protocols, we can have two different types of communications, and the communication between the client and the server goes in a little bit different way. Okay, so when we're talking about the UDP protocol, the communication is very simple. So as you know, if you don't, we're gonna learn on the transport layer protocol lecture. The UDP protocol is a transport layer protocol that is not secure. With this protocol, the server just sends a message to the client, and nothing guarantees that the message arrives, okay, and that the message is accurate, okay. And this is why here we can see the most simple way of communication between client and server. So we send a request, we get a response. Pretty simple. Iterative means that right now we're talking just for one request at a time. Normally the servers can support at the same time multiple communications, but we're gonna take iterative one, so it is more simple, so you understand it a little bit easier. Okay, so let's look at the flow diagram. Okay, so that flow diagram might look a little bit complicated, but it is not. So as you can see here, we're having our client right here, and we're having our server right here. Okay, and with the UDP protocol, here's how communication starts. Firstly, the server has to be on, so it needs to be working as I said. So we have our server socket. Firstly, we fill into the socket the address of the server, our local socket address. Okay. After that, after we fill that, we block the socket and we just wait for some client to connect to us, so we can provide a service to that client. Okay. Once there is a client that comes to the server, it fills the remote socket address. Okay, so now the server knows, okay, I have a client connected to me, let's provide a service, and we get a request. So it handles the service, it provides a response, and after that it continues to wait for any other clients to request something from it. Okay? On the client side, it's also very simple. So we create a socket. We need to know here our local address, and we already know the address of the server. Okay, we know it, we fill it, like so we write the address of the web page that we want to access, and so on. Then we provide the request to the server. Okay, and after that, we're in block state until we receive a response. Once we receive the response, we unblock our socket. Okay, we handle the response, and then we completely destroy the socket. So in the client, once we receive the response from the server, we destroy the socket. It disappears. Okay, and if we want to create a new request, we create the socket again. While on the server side, the socket is always open and ready to do an action. All right. So now let's look at the TCP protocol. So, and actually pay attention here, because this is going to be one of the questions on the quiz that we have for the next week. Okay. I'm gonna give you a hint. So there is going to be a question about what are the different sockets and socket addresses that are used on the TCP protocol. So pay attention here. Okay. So when we're communicating with the TCP protocol, we're having two sockets open at the server side and one socket on the client side. And this is why this transport layer protocol is secured. So applications that use TCP firstly establish a connection through one of the server sockets with the client, and after that, on another socket on the server side, there is a data transfer. Okay, So the client uses one socket for both connection and data transfer, while the server uses one socket for connection establishment and one socket for data transfer. Okay? All right. Now, obviously here we're going to look a little bit more in detail. All right. Okay. So here, actually on the client side, the things are pretty similar because obviously we're using one socket, but on the server side, they're a little bit different. Okay. So here we create the listen socket. So the socket that is responsible for the connection on the server side is called listen socket, and this socket always listens for connections. Okay. So we create the listen socket, then we fill our local socket address, and after that we get the address from the client that needs something from us, and we fill those. Okay. So once we get that, then the connection is established, is accepted, and we block the socket until we start receiving some data. Okay? And this connection always stays no matter what happens until the request completes. Now, why do we need this connection here? If we can just, like in the UDP, we can just skip it and just send the data. So we need that because TCP is a secure protocol. Okay? So this means that if something happens and a message is not sent, then we can record that because of this connection establishment, okay? And we can resend it again to the destination. And this is especially important, for example, if you want to send a file. Obviously, you don't want to lose some part of your files while you send them over the internet. While I told you last time, I think, the UDP is used, for example, if you want to FaceTime somebody. Obviously, if there is some of the messages are not delivered and there is worse quality of the conversation, you don't care because you just want to make the conversation, right? You want to be sure that you talk to the person. Anyways, so once we have the connection here, then the data transfer can start. And here we connect the other socket, which is just called a socket. So the listen socket, so the socket for the connection is called listen socket, while the other one is just called socket. And here we handle the request from the client. Okay, we exchange the data, and once we finish with the data exchange, then we destroy the socket. Okay, so here we destroy the data transfer socket, and then we go back here, and we just wait for other clients to get connected to us. On the client side is pretty similar as you can see. So we create a socket, we fill both addresses, we block. Once the data transfer starts, we unblock, start transferring the data, handle the response from the server, destroy the socket. Okay? Any questions? All right. Let's see what's next. All right. So now, once we know how the connection between the client and the server starts, now we're going to look at the different protocols that are used in the application layer. And we're going to look at the most popular ones so far. So firstly, we're going to talk about the HTTP a little bit, so you understand how is the whole process for accessing website, things over the internet or over any network. And then we're going to move to other important protocols. Yeah, so as I said, the World Wide Web these days is using client-server based service. So obviously we request, so we as the users request a service from a site, and then we're getting those services back to us. And we're using a concept called hypertext, or these days it's called hypermedia. So anyone heard of hypertext? Nobody? Okay, no worries, now we are going to learn about it. So hypertext is pretty much what drives the internet. So when we have a document that is available online, which is a website, right? Then we have two main requirements for this web document or a website. So the first requirement is for that document is to be distributed, so we can access it everywhere around the world, okay? And the other big requirement is for this document to be linked, which means that from one document we can link another document. And this is the same if you go to a website, okay, and you click on another link inside this website, then this transfers you to the next page, right? So let's take this example here that you can see. We have a client and we go to a page. So let's imagine, I'm not going to say a website because a website is a little bit different than a page. So let's say we access a page, and this page has two links inside. So page A has link to page B and link to page C, okay? And link and page A and B are on the same site. So one site can hold multiple pages. As you know, every website has multiple pages. But also, if you go to a web page, it can have a link to another site. So let's see how that works. So we go to link A and we request from site 1 to give us link or actually page A, okay? And the site is giving us page A. On page A we have links to the picture B and the other page C. So if we click on the image on the image B, for example, if you want to see an image, then we're going to do a request to the same website since the link for this image is on the same site, okay? But if you want to get to the page C that is from another website, let's say we go to Facebook, we have a page on Facebook and we click a page on Google, for example, we're going to go to the site of Google and get the page from there. So we need to do another request, and obviously the site Google will give us a response. It's important also to mention that every link can be also accessed independently. So not only a link to page, but also a link to image, video, and so on can be accessed independently, even if it's not linked to any other page. So this is what I mean by distributed and linked. So in the internet, the web client is called the browser. And it is called a browser because even practically you're going to the browser when you want to get some service or to reach some website, right? So the browser provides the services to the users and accesses any server. So let's see how a browser works. So a browser has a controller which accesses inputs from the keyboard, okay? And after it gets those inputs, then it uses the well-known application layer protocols to interpret the page that we get. For example, if we get a website, it is going to use the HTTP protocol for us to have the website. But when we receive the website represented in the HTTP protocol, obviously it's not going to be good for us to work with it, right? So for that reason we need the interpreters. So every browser also uses HTML, JavaScript, Java, and even other languages to interpret the web pages, okay? Does any one of you know, for example, HTML and JavaScript? They are quite popular. Yeah? Alright, yeah. So we can say that HTML and JavaScript, they are mainly working in the front end, right? So let's say the server can have some script on it that is producing data, and the HTML and the JavaScript are the ones that are representing to you the data in a way that you can interact with it. Okay, so once the page reaches the interpreters, then it goes to your computer or monitor, and you can see and interact with it. All right, so now let's talk a little bit about the different components of a URL. Okay, so when you go to the browser and you type some website, you're obviously using a few components in the website description. Okay, so the first thing that you're using is the protocol. As I said before, the protocol, let's say if we use the HTTP protocol, we write HTTP, okay, colon, 2 slashes, and then the rest. So firstly, always we need to define the protocol. If we want to download a file through a browser, we can also do that, and we need to specify the FTP protocol. Okay, after that, we have the host. And the host is normally the IP address of the site that we want to access. Okay. Okay. So as I said, this is the IP address. However, we're seeing a name into our browser. This is because we translated the IP addresses to name using the DNS service. Okay. So this is the host. After that, in some cases, not in every case, I would say, even in most of the cases we don't use that. Sometimes you need to also provide the port. But you know, when you try to access a website on the internet, you never provide a port, right? So normally you need to provide a port if you use an application or go or get a service from a server that is not covered in the well-known protocols. Okay, for example, if you run an application, okay, let's say I write a program on Flask, and this is a program, or actually a framework, that can build web applications. Okay, so if I write a Python program on Flask, and then I want to access that in my browser, I will also need to provide my local port at which I can access this type of application. Okay, so it's in very limited cases that you actually need to provide a port. Okay, and finally, you need to provide the path. And the path is obviously if you go to a site, let's say again google.com, and you want to access a specific page, you need to find the page with a slash and then the name of that page. Or if you want to find a file or a video, again you need to provide some path to that place. You understand that, guys, right? Because I mean you're using this every day, correct? More or less. Okay. Now, another thing that we need to talk about is the type of the documents that we can access. So as you can see, those can be static, dynamic, and active. Okay. So static document, I'll first say about static, and then I will give you to try with the dynamic what it is. So the static document is created once, so all that you see on this static document has been put there at the creation, and it hasn't been changed. Okay, so this is, for example, if you access a blog page, okay, and then the text there is already written, you're not seeing anything specific for the user. Okay, so those are static documents or static pages. So what are dynamic documents? What do you think?
Content changes. Dynamically.
What changes? Say again.
Content.
Content.
Yeah. Content of the web page changes. Dynamically.
For example, what type of content?
Images on the web page.
The what?
Images on the web page.
Yeah. Okay. Yes. Yes. What else can be on dynamic documents? What do you think? Where they would be useful? Or dynamic pages? Okay. Let's say. What, you guys on the back? Any ideas? No?
If you want to use a particular document, then you can use it.
A particular, like specific to us, maybe?
It
Maybe, yes.
responds to the user.
Say
It
again?
responds to the user.
Yes, correct.
Capture.
Say, yeah, no problem.
Capture.
Yeah, okay. Yes, that's capture is for sure a dynamic document, yes, that's good. But yeah, so dynamic documents are the ones uh, that have information specific to the user. And how this information is getting specific to the user. For example, you have a database where you hold some user information. Okay, let's say you go to your, I don't know if you're into social networks, but for sure some of you have either Facebook, Instagram, or anything else, right? So when you go to your page, you see your name, right? Other users see their names. So it really depends on what user is logged into the account, on the information that you're going to see, okay? Also, if you're into, okay, if you buy items from Amazon, obviously the items that you see in your cart are going to be different from the items that other users see, okay? And these are dynamic pages. So if you see the code of the page, you have a space where it's not specifically defined what the user is going to see, but there is some variable depending on the user, right? Okay, and finally, the active documents are those documents that have some script incorporated inside them. For example, sometimes you're going to web pages that have animations, right? Let's say you're moving your cursor and it's not something standard, right? Sometimes you go to a web page where when you move up and down, you know, some graphics happen. So those are active documents, which means that there is a small script inside, uh, let's say, the HTML file that you receive, okay? And this script provides those graphics. One actually very popular framework for coding that is called GSAP. It's in JavaScript, okay? And this is, for example, if you want to build websites with graphics, you can use that. It has predefined scripts that you can call with one command, and then you can create active pages. Okay. All right. So I'm not going to get today too much into the specific requests and responses of the HTTP. We're going to do that in the other lecture because we need to cover this very extensive. But for now, what you need to know is that we're doing a request from our devices to the server, and then the server provides all services. Now, what we're going to cover today are the two types of ways that we can get our pages. Okay. Okay. And so those two types of connection using HTTP is persistent and non-persistent. Okay, so why do we need two different types? So I'll first start with a non-persistent, which is a more simple form. Okay, let's say if you want to get two pages from a site, our requests will be handled separately. So we will do one request, we will get a response. We will do another request, we will get a response. And sometimes this can be improved. Okay, so this is an example of non-persistent connection. So if our pages are both on the same site, there is no need for two requests. Sometimes we can use a TCP connection, so we can establish the connection, and we can get both pages at the same time with a data transfer. And this is a persistent connection to get our HTTP data. Okay, so that's gonna be all for the HTTP. And yeah, next time we're going to talk more about HTTP and also other services related to this protocol. All right. All right. So the FTP protocol. So what is the FTP protocol used for? I think it's written, right? For file transfer. So If we want to get a file from a server, we are going to use this protocol to get the file securely. So sometimes the server and the client, use different operating systems and understand different types of characters, files, and so on. So for that reason, we need some standard when we exchange files from one application to another. And the file transfer protocol does that in a very secure and simple way. Obviously, you can see from the graph that logically it uses the TCP protocol for communicating, and we have one control connection. So we have one control connection that's established between the client and the server, that's always there, and then we have the file transfer process, which ends when we transfer all the files. Okay, and on the client side we have the user interface, obviously, where we can actually get our files and work with them. Okay. Now, we saw that. Actually, I'm just going to bring it back so you can make a relation. Okay. So we saw that we have a control process and a data transfer process. But what are those things like? Why? How we're interacting with those two type of connections and processes? So let's see that. Now, when we're talking from a client to the server, some protocols are using some specific commands in order to say to the server what to do. Okay, so for this reason we need this first connection that you saw. For this reason we need a control process. So in the control process we're actually sending those commands that do different things, okay, to specify what type of file transfer we want. So maybe we want to just list all the files that we have in the remote directory. Maybe we want to upload a file. Maybe we want to download a file. The server needs to know what do we want to do. And for that reason, we're using those commands, and you'll see an example later. And after that, the server sends us those codes, okay, in the response to notify the client what happened. Did we do the things right? Is there a problem with the request that we sent? For example, 200 means that the command went okay, right? This is very common. And I'll show you an exact graph on how this works. Okay, actually we're gonna pass that. Yeah. Okay. So you can take a look here. It's more simple to work with graphs, right? You can see the things exactly how they happen. So now here we have our client, and here we have our server. With the gray, you can see the control process, while with the blue, you can see the data transfer process. So the control process uses port 21 always for communication, and then the data transfer uses port 20. Those are predefined ports. So what's happening? Firstly, the server should be on, so it provides this code to 20 that the service is ready to use. After that, we send the user, okay, the username from the client, and after that, the server is asking us for a password. We provide the password, and then we say, the server says, okay, the password is good, so let's continue. Okay, so then we provide the port on which we want to get the file transfer. Okay, and then we get a message that the data connection will start shortly. Okay, so now here on those lines, the client is going to tell to the server what type of service do we want to do. Okay, and let's remember those and see them on our table for the commands. So let's say this one, ASTRUR. I'll just bring the table. Okay, so if you see here, strur means that we want to get a record, right? So we can choose between file, report, and a page. So now our server knows what we want to do. Okay, so once we provide those instructions, and obviously if you're using a browser, everything here is happening into the background, right? You don't need to write those commands. You normally interact something into the user interface. After you provide all of those, the server says okay, and then the file transfer starts. Once the file transfer ends, okay, then we end the connection. We do need a separate communication here for the data transfer because we might want to transfer multiple files. So this connection is open until we transfer all the files from the server to the client, or if you want to upload all the files to the server. Then we stop the connection, and then the service is closed. Okay, so that was pretty simple, right? One client, one server, they're communicating pretty easy. But now with email transfer, the things get a little bit more complicated. But if you understood what I explained you so far, you understand that as well. All right, let's get into it. All right, so when we want to send an email, we need multiple client-server communications. And this is because if you imagine an email, we imagine an email as a one-way street. So if you want to send an email to somebody, you don't necessarily expect a response, right? You don't necessarily expect this person to answer to you. You just want to send it there and that's it. Also on another side, if let's say you want to send an email to me, right? I need to have my laptop on all the time because if I'm the server and you're the client that is sending me an email, if I want to receive your email, I need to have my laptop continuously running. Otherwise, I might miss it. Okay? So this means that this wouldn't work. You know, it's not very practical. So for that reason, we need to have slightly different architecture if we still want to use the client-server architecture here. And this is why we create this architecture right here. So we need 3 client-server processes in order to send emails. And this is really the actual way how emails are sent these days. If you have a Gmail, right, which you have because in Fieldwork everybody has used Gmail, this is exactly how you are going to send and receive your email. So you're going to have a user agent, okay, which will help you to write the email, okay, and then you will have 2 email servers, okay, one on the sender side and one on the receiver side, okay, and those email servers, each, as you can see, has some server here and some client here, okay. So let's see how the whole process goes. Now, we have 2 types of agents, which is the MK, which I think was the message transfer agent, and this is the message assess agent, okay? So the message transfer agent is responsible for sending emails. It has nothing to do with getting the emails. The message assess agent is responsible for retrieving and getting the emails, okay? So when you want to send an email, you're going to write it, and then from your MTA client, the message transfer client, you are going to send this to the message transfer server, which is encapsulated here into this email server, okay? Then inside, all the emails that you send, they are going to be queued. let's take the example with one email. So one email is going to be provided from this server, you know, the mail server, it's already inside, okay? So it's going to go to another MPA component, but this time an MPA client. So what clients do? They pretty much do services to servers, right? So the client then will communicate with the MPA server on the other side, and it will send this email over the internet. Okay. So once we get the email on the box email server, so for example, I can use Yahoo. So let's say this is Yahoo mail server, this is Gmail mail server. Okay. So Bob gets his email into the MPA server. Obviously, on the Gmail, for example, everybody has a different mailbox. So Bob will have a specific mailbox that is his, that he has the credentials for. Then his email is going to be stored in his specific box, or in a practical way, just under his name, his email name. Okay, this will be related to his email name. And after that, we use the MAA, or the message access agent server. And what Bob will do, he will just use his client to send a request to the MAA server and get the email to his user agent, you know, and be able to read it. Okay. So this is the whole idea on how you receive emails. You just need three request receive, client, server connections. And you should remember that the message transfer agent is a push agent, so we push the message, while the message access agent is a pull agent. Okay. So let's first talk about the user agent, okay, or what's happening when we write emails. Okay, so as I said, everybody has its own mailbox on the mail server, okay, and you have the mailbox address, okay, which is your unique name. Yeah, come in. So you have the mailbox address, and also you have the mailbox domain name. This is normally, the domain name is usually the name of your what? Mail server. So you have at gmail.com, at yahoo.com, okay? So this is what it will identify. So here on the figure below, you can get some idea and some comparison between a postal mail, a normal postal mail, and also an electronic mail. As you can see, they are pretty similar. So firstly, we have the envelope, which you can also have a digital envelope that has the sender address and the receiver address, just like in the real world. Then you have the header, which is pretty much the subject, the dates. We all know how it works. We all know the information that we see when we receive an email, even before reading it, right? You get the subject for sure. And after that, you have the body, which is obviously the actual message or the actual email that you want to send. And this is what is done in the user agent. Normally, of course, you're using a user interface, a graphical user interface, to write your emails. And once you click the send button, then they start going through the MTA and the MAA. All right. Okay. So now we can talk a little bit about the protocols, since now we know how a message is sent. Obviously, the different clients and servers use different protocol. That makes sense, right? Because if you want to push an email, we have one set of rules. If we want to pull an email, we get other set of rules. So so between the client and the server of the message transfer agent, we are using a protocol called SMTP protocol, which is responsible for pushing your email, for sending it. As you can see on the message access agent, we have two other types of protocols, which are POP. These days we use the third version of the POP protocol called POP3, and also the IMAP protocol. But here is important to remember that the two protocols, so we have different types of protocols on the MTA side and on the MAA side, and we're going to talk about those. Now here, before jumping into the SMTP, okay, here are the different commands that are used with the SMTP protocol. So this is something very similar to the file transfer, right? So where we have some control, so we send some commands to the MTA server, and we're getting some response with those codes over there. You can use that as a reference, but I will show you how it looks like on the actual graph. All right. So, as we said, the SMTP protocol is used two times: to send our email to our mail server, and our mail server to send the message to the remote mail server. So how everything works. Now, you can see, again, just like in the FTP, the server is ready, and we initiate communication from here. Then the SMTP server says, okay, we establish the connection, okay, and after that we send the envelope. As I said, we're sending our mail, okay, and the email of the receiver. After that, we send the header of our mail. This will be the subject, the date, and so on. And after that, we're just going to send the body of the mail, and then we'll quit the service. It's pretty simple, nothing too complicated. Okay. Now, as I said, on the message access agent, we're using the POP and IMAP protocol. So first I'm going to talk about the POP protocol, which is more simple. So what we have, when the mail service was first built, the POP protocol was the first protocol used. So this protocol is used for us to retrieve our mails from the email server. And how this is done? The client provides a username and a password. Then we can send the commands to list our emails, and then we just send the specific email and identifier of the specific email which we want to get. So there are two ways to get emails from using the POP3 protocol. So one of them allows you to just download a copy and keep your email on the POP server, while the other one, once you get your email, it deletes your mail from the remote server. Okay. So on the top of the POP3 was built the IMAP protocol, and this is a little bit more advanced protocol comparing to the POP3 because it allows you to do a few more things comparing to the POP3. So here, even before downloading, you're able to check your email header. You're able to search your mails as well. You can create, delete, or rename your mailboxes, right? So you can also do that using the MAA as well, and so on. There is nothing more specific in the IMAP protocol comparing to the POP3, but IMAP is more suitable because it has a little bit more features compared to POP3. POP3 is a little bit more simple type of protocol. Um, and finally, we need another additional protocol when we send emails that is used just before shooting the email to the mail server. And this is the MIME protocol. So normally, when we create an email, it is created with, or we expect and we understand the ASCII characters, which are only English characters, right? If we want to send an email on another type of language, for example, I'm originally from Bulgaria and we use a different alphabet from English. So if I want to send an email in my own language, this won't work, okay? So for that reason, we need some other type of protocol before transferring the message to the email system. So for that reason, we use the MIME protocol. So the MIME protocol converts the non-ACI code, right, or like different languages, even graphics, into the ACI language. And we're also using a service called NVT, which is a standard among many protocols, and it's used. So we have some common type of data that would transfer between the servers or over the internet before reading it into the receiver. Okay. Now, I know that now when I was talking about sending, receiving emails, most of you were probably imagining accessing your email through the web, right? You didn't imagine accessing it through your local mailboxes, because I think most of the time we're using exactly that. I think some people, actually me at my work, I'm still using Outlook, which is a local mailbox, but most of us are using web-based email. So when we're using web-based email, when we receive a message or we send a message through the web, for example, when you access your Gmail, obviously you go to the browser, you type your gmail.com, you access your email address and so on. And this means that you're accessing your emails using different protocol. You're actually using the HTTP protocol, which is the one used for the pages, right? So for that reason, of course, here there are two scenarios. One of them is if I use a local mail sending to somebody that is using webmail, whatever. As you can see, I'm going to use SMTP protocol for my local mail, sending it to the mail server. Then the transfer from server to server is happening in SMTP. And the person that is using a web client is using the HTTP protocol as a replacement of the POP3 or IMAP, right? Here, if we're both using the web-based email service, we're only using the SMTP protocol when we transfer the email from one mail server to another one. So the SMTP protocol is always used. But as you can see, to send and to receive mails, we can also do that these days with HTTP protocol as well, which is quite useful. Or yeah, I was going to ask for questions.
So HTTP connection that is being made is for POP3 or IMAP, right?
The what? Sorry.
HTTP server and HTTP client, the connection between them is because of POP3 and IMAP, right?
So here, no. So here we use the HTTP protocol here as well.
Now, is it because of POP3 and IMAP?
You mean right here? Or?
Yeah. Because we have a server, SMTP server, so are we going to download the emails in POP3 from HTTP server or SMTP server?
So if you use a local client, right, not a browser or web-based client, you're going to use POP3 or IMAP when you download the email, right? But if you're using a web server, right, or not web server, if you use a web client to access your email, then you're going to use the HTTP so you're going to eliminate the need for the bottleneck. Is that answering your question? Yeah. Okay. Now, are there any other questions? Because now we're moving to Telnet and SSH. So, any other questions for the mail transfer? No? Okay, so assume you understood everything. You get the test with 100%. Okay. Telnet. Does anyone knows what Telnet is and what it's used for? Yep.
It's a secure protocol to connect to a device or machine inside a network.
Yeah, you are right. Yes, it is a protocol to connect to device or machine. That's
A
correct.
secure protocol.
But I would challenge how secure it is, although there is some level for security. Have you used Telnet protocol to connect to device, or you?
Yes, I did.
Nice. Yeah, so Telnet is exactly how you say. It is used for remote logging to a device. Why do we need remote logging? Obviously, sometimes we just want to interact with the server in any way we like, and we don't want to think of so many different protocols that we want to create for an application to interact with the server. We just want to connect to it and do stuff there. For example, let's say I'm a student and I have a pretty old computer, but I want to use, let's say, Java to write code. I can skip using my computer and I can use some university computer, remote log to it, and use the services from this remote computer, right? And to do that, I can use two protocols. The first one we're going to talk about is the Telnet. And I've actually used Telnet. These days, it's not really popular, especially to use it over the internet because of security issues. But sometimes some companies use it, especially on a local network. For example, if you have a switch to which are connected multiple computers and you want to access each of those, you can just access the port at which every computer is connected, and you can use Telnet. Normally you do Telnet, you provide the IP address, okay, and then you're also going to provide a specific port to which each device is connected. But let's see the graphs here. So, yes. Okay. Okay, so you can understand a little bit better. So we have two cases. One is local logging, and the other one is remote logging. So this is where we use the Telnet client. So let's first see what's happening in the local logging. For local logging, we use a terminal. So if you write on your computer terminal, then you write commands, and you can do pretty much everything on your computer. You can access all the different types. Actually, you should be able to access all the applications on your device using terminal driver. So what you do from your computer, you access the terminal driver. It handles on the background all the rest of the protocols in the operating system, and the commands you write to the terminal, it translates them into the actions for the applications, right? Now let's see what's happening when we do remote logging. So when we do remote logging, obviously we want to access some other system or device. So let's say this is our computer, and this is the computer that we want to access. So again, here we have a terminal driver, right? So what we're going to do firstly, we're going to establish a connection. So we'll write Telnet, the IP address, the port, and so on to connect to our to the other device, right? And then we want to send commands to that device. So everything we write on our computer, we want to do actions on the other computer. So how does happen? We use again our terminal driver for that. So every command then goes through the Telnet client. Okay? And this is in the application layer. After that, it passes through the rest of the protocols, which are in the operating system, so we don't care about them. Transfers the message to the internet, and after that it goes to the telnet server on the other side. We have a logical connection between the application layers here. Okay, but now remember the applications, they understand terminal driver commands. They don't understand telnet commands, and for that reason, every operating system also has the pseudo terminal driver. What this does, it is translating the terminal, the telnet server commands to a normal terminal driver commands that can be understood from the applications. Okay, and this is how the code communication into the telnet layer or the telnet client and server actually is happening inside the application layer. Any questions? Understood? Okay. Okay. So there is one thing that I did not mention when talking for how we establish connections between telnet client and server, and this is the NVT character set. So the logic is exactly the same as when we're using the web-based mailing. So obviously we need to have the characters sent through the internet in some character set that is understood by anybody. For example, there is no guarantee that my computer will understand exactly the same type of characters and commands and text like the computer I'm communicating with. So for that reason, we need some standard for the characters that are sent. Okay, and for that reason, before telnet sends the message over the internet, it transforms the message that we want to send or the command into NVT character set that is understood by the other telnet server. So the remote computer is then using the telnet server to translate those NVT characters to characters that are understood by the remote computer. Okay, and after that, once we have that character set, then we go to the pseudo terminal and we finally send the commands to the application. Now, anyone knows what SSH is?
It's a predecessor of telnet.
It's what?
Predecessor of telnet, like a new thing. Same, like it helps you connect with a remote machine.
Yeah. So yeah, exactly. So it comes after the telnet. So yeah, because there were a lot of security issues with telnet, then the SSH or the secure shell was created. And actually, I will try. We have one lecture that is going to be a little bit more practical. So we're going to write some code. I will try to show you exactly how you can connect with telnet and SSH, because of all the things that we're learning here, for sure those two, I'm sure in one or another way you're going to use them at some point in your work. So it's worth seeing those in a little bit more practical way. But yeah, SSH is used also for remote logging, but it is more secure because it has quite a different architecture from the telnet. Okay, so there were a few versions of the SSH. I think the latest one is the SSH2, which has this structure that you can see on the left. So what SSH is doing, once you establish communication between a client and a server, it creates additional 3 layers between the TCP the TCP layer or the transport layer and the application layer. Okay, and as you can see, those are the SSH trans, SSH out, and SSH con. Okay, and we're going to just cover those, learn what they do pretty briefly, and then I think I will let you go. Yeah. Okay. Now, here on the right side, you can see a little bit of the advantages of the SSH protocol. Obviously, it's more complicated and provides more advantages. So, the first one is privacy and confidentiality. It's more secure. It ensures that nobody else will get the messages that you exchange with the server. Okay. Then when I wrote there data integrity, this means that we're sure that the message that we sent is received and it didn't change while we were sending it. Nothing in the message changed. Okay, this ensures that. Obviously, it provides better authentication, meaning that we can be sure that the server that we connect with is the right server and the exact server that we're looking for. Okay, and finally, it provides compression of the messages, which means that when we send the message, it is more compressed, it takes less space, so the communication is faster. Okay. Now, let's see if I. Okay. Now let's talk about the different layers. Okay. So firstly, in the SSH trans, we include things like the username. Here we also write the password. Okay, so this is the first layer, and this so you know the TCP is already the TCP protocol is already having a little bit better security than the UDP, but the SSH trans provides a slightly better way of security comparing to the TCP. Then into the authentication layer, the username, the password, and all those credentials are verified. Okay, and finally in the SSH Comm we are performing the actual connection, and we're opening a few logical channels, and over those logical channels we can interact with different applications and pretty much everything that we want to access on the remote host. Okay. Now, finally, there is one very nice feature of the SSH protocol, and this is the tunneling. So, SSH really became a very popular protocol, and it's used pretty much all the time when we want to do a remote connection, and even sometimes it is used for an extra level of security with the other protocols. Sometimes you're even going to use telnet on the top of the SSH client just to add extra level of security. This is also true for file transfer. So many applications would have the FTP protocol on the top, then they will have SSH, create a tunnel between the SSH client and server, and we'll start exchanging the file for extra level of security. Also, when you do remote connection to a server, you can use the sftp command if you want to securely copy a file from the server to your local device. Okay, so I think that's it. Okay, yes. So that's it all, guys, all the protocols. Any questions for the telnet or SSH? Okay, everything's clear, that's good. Good, so you will I will release a quiz, another one for the topics that we covered today. Last time I know I promised that I will give you a video, but there were some technical issues with my laptop, so I didn't have the sound, but this time it should be fine. So I will upload a video from today's lecture so you can watch it at your own time if you want to see something again. Again, you have the reference, which is a PDF document. It's about 40 pages. Please go over it. If you listen to the lecture, you should be able to go through it very quickly. It should not take too much time. I would advise you to read it and then take the test. Okay. Now, has there been anybody that didn't take the last test yet? The one from the previous lecture. Okay. Because I think I see there are a few people that didn't, but let me see which are those. Yeah, the last quiz. You didn't take it yet? Oh. Yeah. No. Oh, I see. So were you not able to see that it's released, or you just had like, because I just want to make sure that everybody can assess it. You can assess it, right? Okay. I will give you, because it's the first week, I will give a deadline until tomorrow evening. If you can, read reference 1 and just go through it, shouldn't be that hard. Okay. Anyone else? Okay. So what was your name? Just to how? Okay, William. Yeah, I see you haven't taken. Do we have Wakshmi? Wakshmi? No. Okay. And who else? Chetan? Okay. Okay, I think that's it. All right, I will find those people my own. But that should be that should be everything, guys. So if some of you haven't done the test, which I think the rest of you did it, I will give additional deadline until tomorrow evening. Okay, for the first time, and the next test you have time to complete it until our next lecture. So next Thursday, I will set the deadline until 12 a.m. Okay, sounds good. All right. Before going, any other questions for anything, for the material or anything else? Grading, assignments? Okay, good. Have a good evening. Thank you very much. I hope you learned the things.